up, y'all? It's Mari here with First Updates Now, and today I'm interviewing 2583 Orange Dynamite. I have 4 students with me. I have Brian, Gavin, Andrew, and Hashit, and we're going to be going through their robot. They have a pretty cool one that does both cubes and cones and can do everything. All the height, all everything.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Kettering University is looking for talented robotics students who want to continue learning and innovating in a hands-on, real-world experience format. Kettering University representatives will be at dozens of FIRST events this season, including the championship. Go to kettering.edu/first to see which events you can meet a Kettering University representative. FRC competition season is here. Submit your favorite moments to FRC Clips of the Week by each Sunday at discord.gg/firstupdatesnow. Also, the FRC Top 25 poll is open Sunday 5 p.m. Eastern to Monday 5 p.m. Eastern, where you can vote for your top 25 teams of the week at firstupdatesnow.com/FRC Top 25.
First off, we're going to hit it with Gavin, and we're going to talk about their chassis. So, some of the cool things you want to mention?
Okay, yeah, so first our swerve. We have it geared to have really high torque, but we're able to push these Falcons so that it can go also extremely fast, which makes us very mobile and able to play both offense and defense. And then we have weights in the front. We've actually placed extra weight in the front where it lets us reach way further behind us without the robot trying to tip over. And to hold all of this like above the ground, we have a bunch of metal instead of polycarb like last time, which lets us like zip tie into it, so we can hold things down onto it much easier.
Super cool. I'm a huge fan of the weights. Now we're going to move up in the robot to the transport and its wrist that holds on the intake. So Gavin, do you want to talk to me a little bit about that?
So our transport is basically just a 3-axis arm, one to rotate it, or like the whole system over the robot, one down here to make the intake come out so we're able to pick up from the ground and adjust if ever we need to when we're picking up from the shelf. And the third one, which allows us to pick up cones from the ground and then go over and be able to score them, because if you're just to pick them up from the ground and go over, the cones would just be upside down. So the wrist allows us to do a 180 and put them upside on the right side up. Yeah. Another cool thing is we had old tank drive like gearboxes that we didn't use, and we found one and we put Falcons onto it, which allow us like 10-to-1 gear reduction, which helps us get to this next axle, which is around a 50-to-1 gear reduction, and then another one here, which is around an 11 gear reduction, which in total is about 250, which allows us to keep the arm still, along with these counter springs, which are attached to two dead axles, one on the back of the arm and one in the middle of our superstructure.
Loving the fact that y'all had the pre-planning to counteract the arm with those weights at the chassis, but in terms of getting it up quick enough, I guess that's a question that code has. So you want to talk to us about your presets and overall coding stuff?
Of course. So with coding, we basically programmed our arm and all the wrists to simultaneously move to the right positions. So let's say I want to go back to starting configuration. All I need to do is press a button, and all the things go back to 0 position. We have programmed all our different parts, our 3 rotation axes of rotation, to using tick values. We measure the ticks of each of the Falcons and set them to the different positions that we need to easily get to the different stages of scoring and as well as the shelf. So we have scoring. We have positions for the starting configuration to keep the cone and cube inside a robot as to not drop it really easily. And then we have ground position allowing us to pick things off the floor, a shelf position to pick things up off the shelf in the loading zone, And this also doubles as a mid position for cubes and cones. And then finally, we have a high position in the very back. We have to flip all the way over our robot to get to high position, and we fully extend our robot. And using code, we've also ensured that we don't go past the height limit, because with our robot fully extended all the way up, it does pass the height limit. But using code, we've made sure that the arm is tucked in before we go all the way over. So we've set this to high position, and over the back, we've also set to middle position. And all we have to do is press one button, and it goes all the way back to start position.
That's super cool. I'm very proud of you guys for being able to make sure you don't hit that height limit with code. Speaking of the intake, we're gonna hit it over with Hashit, and he's gonna give us a little bit of a go around with it.
Oh, well, yeah. So, well, with the intake, we had many different designs that we were initially looking at, but after looking at a team called Mechanical Advantage, we found this intake design. We mimicked their intake design and made this one, which looks kind of similar to theirs. And so the advantage of this intake is it can pick up cones and cubes really fast and really efficiently. As you put a cone onto these metal wheels, if I put a cone on these metal wheels, they'll go into these, and it's just, if you push them hard enough, they'll get stuck, which we can't do it manually, but these motors, when run, will push them hard enough that even when moving upwards, when jiggling, they can keep themselves stable. And so these two pulleys allow for the amount of torque that we need to keep these cones in brake, and so that they don't fall. We can also eject these cones and cubes. So instead of going all the way around for cubes, we can just go to the same position as the shelf position to pick up the cubes and drop them in the high goal in the same way. That's an example of how fast our intake can pick up the cubes, and then it can also launch them if need be.
Y'all had a really good run at this competition, and I'm very proud and happy to get to see y'all and interview you guys. So once again, this has been 2583 Orange Dynamite at Belton FIT competition. We look forward to see how y'all do at Houston. So good luck with the rest of your run. Have fun this season.
Thank you.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Kettering University is looking for talented robotics students who want to continue learning and innovating in a hands-on, real-world experience format. Kettering University representatives will be at dozens of FIRST events this season, including the championship. Go to kettering.edu/first to see which events you can meet a Kettering University representative. FRC competition season is here. Submit your favorite moments to FRC Clips of the Week by each Sunday at discord.gg/firstupdatesnow. Also, the FRC Top 25 poll is open Sunday 5 p.m. Eastern to Monday 5 p.m. Eastern, where you can vote for your top 25 teams of the week at firstupdatesnow.com/FRC Top 25. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.